Hi guys, the problem today that we are going to solve is top view and bottom view of the tree. As the name itself suggests, to find the top view of the tree, the top view is however the tree would look if seen from the top. So if I draw a line like this, so this will be the top view. If I write the top view would be 8, 4, 2, 1, 3, 7 and 14. This is the top view. Similarly, the bottom view would be however the tree would look if you see the tree from the bottom. So it will be 8, 10, 9, 11, 12, 13, 15 and so on. Okay, the trick in solving this problem is we find something called horizontal distance. See, while we wrote the solution, we traversed from left and went towards the right direction. So we keep track of something called horizontal distance. I'll write the horizontal distance for every node to make that clear. Let's say we start from the first node, root node, and I'll give a horizontal distance. I'll assume some arbitrary value, let's say 0. Okay, so whenever I am moving to the left, my horizontal distance from the leftmost will decrease. So I will decrement it by 1. And whenever I am moving right, the horizontal distance from the leftmost will increase by let's say 1 unit. So I will increment it. So 0 will be 1. Whenever I am moving left, I will subtract 1. Whenever I am moving left, I will subtract 1. Similarly, when I am moving right, I will add 1 to the horizontal distance from the previous parent node. So this will be minus 1 plus 1 will be 0. Similarly, minus 2 plus 1 will be minus 1. Similarly, minus 1, I am coming to the left, so I am decrementing. Horizontal distance is minus 2. Similarly, minus 1 plus 1 is 0. Likewise, if I fill the values, this will be the horizontal distance. Okay, so these are the horizontal distances that we got, and as you can observe, the leftmost node that you can see, which is 8, is having the least horizontal distance. Once you find the horizontal distance for every node, what we'll do is we'll keep a mapping. We'll build a mapping from horizontal distance to value of nodes. How do we do this? Once you find the horizontal distance, you start with the least horizontal distance, and for every value of horizontal distance till the maximum value, you keep a mapping. So minus 3, minus 2, minus 1, 0, 1, 2 and 3. So these are all the horizontal distances. Now to fill this mapping, what we will do is we will do a level order traversal or breadth first traversal. In the breadth first traversal, we will traverse level by level, and for each level when you are traversing down the tree, for each level we will see if my map is empty for some particular horizontal distance. If it is empty, I will fill that value into this map. If it's not empty, I will simply move on. So for minus 3, if we do a level order traversal, in the first level for 0, the mapping is empty, so we fill this map with 1. Next, if we move to the next level in the level order traversal, in the second level for minus 1, corresponding map value is empty, so we fill this. Similarly, for 1, map value is 3, which is empty, so we fill this. Now coming to the next level, in this level the elements are 4, 5, 6 and 7. For simplicity's sake, I have written 6 to the bottom of 5. Okay, in this level the nodes are 4, 5, 6 and 7. For 4, corresponding horizontal distance is -2. -2's mapping is empty, so we fill it with 4. For 5, corresponding horizontal distance value is 0, but 0 is already filled, so we will move on. For this node, horizontal distance is 0. For 0, it's already filled, so we move on. For horizontal distance of 2, the map value is empty, so we'll fill it with 7. Similarly, moving to the next level, in this level the nodes are 8, 9, 12 and 14. So for 8, for each of these nodes we'll consider the horizontal distance and we'll write its value into the map if it's already empty. Okay, for -3 the corresponding mapping is empty, so we fill it with the node's value, which is 8. Similarly, for 9, its horizontal distance is -1. -1 is already filled. Similarly, for 1, mapping is already filled. Similarly, for 3, 14's corresponding horizontal distance is 3. For 3, the mapping is empty, so we fill it with the value of the node. Now, what did we get? We got the top view of the binary tree. How did we get the top view? We calculate the horizontal distance of every node and store it somewhere. Let's say as a mapping from the address of the node to the horizontal distance. We first store for each node. We'll find and store horizontal distance. And once we find the horizontal distance, we take the least HD till the maximum HD and build a mapping. How do we build the mapping? We do level order traversal, and for every level we consider the nodes and its corresponding HD value, and we'll see if the mapping is empty. If it is empty, we'll fill that value, corresponding nodes value, into the map. Similarly, we continue until we traverse the whole tree level by level. Once we are done with traversing, we just print this value. This is the top node. Similarly, to find the bottom node, the bottom view of the binary tree, what we will do? First, we will find the horizontal distance. Just like how we found for top view, first we will find the horizontal distance and we store it for every node. Now, after that, we will do the same thing. We will build a mapping. Here also, we will build a mapping from horizontal distance to the value of nodes. In this mapping, now to find the bottom view, what we will do is, if my map is empty, I will enter that value in the map. But if it is not empty, if a value is already filled, we will still update the map. So whenever we are moving down the level, we will start the first level. For 0, in the first level, the only node is 1, its horizontal distance is 0. We look into the mapping, it's empty, so we'll write 1, update the map. Similarly, for the second level, for -1 and 1, the node values are 2 and 3. Their map value is empty, I updated the map. Similarly, for third level, if you look into the third level, -2's corresponding mapping value is empty, so I fill it with 4. But for 5, the map is not empty. But here, since we are finding the bottom view of the tree, we are looking from the bottom, and so we need to keep track of the last node which has the corresponding horizontal distance. So here, while finding the bottom view, you will update the map. So for 5, horizontal distance HD was 0, which was not empty, but we still update the map while finding bottom view. Okay, so and then the next node is 6. It has a corresponding horizontal distance of 0, which is not empty. Mapping is not empty, but we still anyway update the map. So it is 6. For 2, map was empty. We'll fill it. Similarly, we move to the next level. In this level, for -3, the horizontal mapping value is empty, so we fill it with 8. For -1, it was 9. It was non-empty, but still we updated. Similarly, for 1, we updated with 12. We updated with 12. For 3, the mapping is empty. We write 14. Moving to the next level, what we have here are 10, 11, and 13. So for 10, horizontal distance was -2. We'll update it with 10. For 0, we'll update it with 11. For 2, we'll update it with 13. Moving to the next level, in this level 15 is the only node which has a horizontal distance of 3. So we'll update this on this. So the bottom view of the tree is 8, 10, 9, 11, 12, 13 and 15. So this is how we find the top view and bottom view. In the next video, we'll implement all the solutions for the both top view and bottom view using C++ or Java. Hope you guys found it useful. Thank you.